Hi, my name is Ankita. We've all wondered where babies come from, right? Well, in my lab, we wonder where blood cells come from, and I'm going to show you why that is just as important. Meet Seth. Seth was born without an immune system, a disorder called Severe Combined Immunodeficiency Disorder, or SCID. When Seth was 5 months old, he received a bone marrow transplant. A bone marrow transplant aims to provide Seth with new bone marrow stem cells that can give rise to a new immune system. A bone marrow transplant can effectively cure any blood-related diseases, just like sickle cell anemia or any other blood cancers. However, bone marrow transplants are extremely complicated and can cause many side effects. One such side effect is graft versus host disease. Graft versus host disease is where donor cells attack a patient's body. That is what happened to Seth. So, how can we get rid of complications like graft versus host disease? We think we can get rid of these complications by giving a patient a perfect match of cells, their own. We can take patient cells, like skin cells, turn them into induced pluripotent stem cells. Pluripotent meaning they can give rise to any cell type of your body. In this case, you would turn them into bone marrow stem cells. Bone marrow stem cells would then replenish the new immune system. However, this process of taking pluripotent stem cells to bone marrow stem cells is not possible thus far. So we need to know more about how a bone marrow stem cell develops. Well, a bone marrow stem cell can give rise to all of the effector cells of your immune system, like the B cell or the T cell. But what gives rise to the bone marrow stem cell? Our lab has found a precursor population that precedes the bone marrow stem cell in development. So if we study the process of maturation between the precursor cell and the bone marrow stem cell, we can duplicate this process in the lab and make bone marrow stem cells. Sounds easy, but it's not, because bone marrow stem cells can arise in many different places in the developing embryo. In this case, we study mice. Mice have many sites of hematopoiesis, or blood origin. So there are many places in the embryo, like the yolk sac, which is a thin membrane surrounding the embryo, the dorsal aorta, which is the main blood vessel of the embryo. All these places can give rise to blood cells that lead to bone marrow stem cells. So which one of these sites actually gives rise to the bone marrow stem cells? Well, we don't know. We have to narrow this down. The way we do this is in our lab, we have created green mice. Mice that glow green in one of the places where blood cells come from. In this case, it's the yolk sac. The yolk sac is green and everything else is red. So when these mice are born and we have green blood cells, we know they came from a green bone marrow cell, and that came from a green precursor cell, which came from a green yolk sac. This way, we can narrow down where this bone marrow stem cell came from. Having these cells glow green also makes them very easy to study. If we know the process that it takes the precursor cell to become a bone marrow stem cell, we can apply it to make the pluripotent stem cell to become a bone marrow stem cell. Seth, by the way, had his second bone marrow transplant a year ago, and he's doing great. He can go to school now. But how can we avoid the complications that Seth faced in the first place, like graft versus host disease? We can take the patient's own cells, turn them into pluripotent stem cells, turn them into bone marrow stem cells, so that by skipping the requirement of a donor, we can begin to heal ourselves. Thank you.